All right, question number 22. Quadrilateral ABCD with vertices A, B, C, and D is shown on the graph. Find the perimeter and round to the nearest hundredth. All right, so I know that in order to find the perimeter, I know that I have to find the distance of all sides and I have to add them up. So I'm going to start with the two easiest ones. I'm just going to count here. So the distance here is 1, 2, 3, 4. So the distance here is 4. Okay. The distance along the bottom is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so those were easy because I could get those through visual inspection. For the other two, I'm going to have to use the distance formula. All right, for the other two sides, for DA and CB, I'm going to have to use the distance formula. So just a reminder, the distance formula is distance is equal to the square root of the difference of the x's squared plus the difference of the y's squared. Okay? And don't forget your squares. All right, so I'm looking at my first point, and I'm going to find the distance of DA first. Okay, so I'm going to go ahead and open up my square root. I've got my second x minus my first, so -2 minus -6, so -2 plus 6 squared, plus my y's, which would be 2 minus 0 squared. All right, I'm going to type that into my calculator, and I get the square root of 20. Okay, I'm going to leave that exactly as it is right now, and I'm not going to do any rounding. I'm just going to leave it as the square root of 20. I'll do my rounding in the end. All right, now I'm going to find the distance of CB. Okay, I'm going to use the exact same formula. So open up my parentheses, or excuse me, open up my radical, and I've got my second x, which is my 6, minus my first one, which is 2, squared, plus my second y minus my first one squared. Okay, I'm going to type all of that in the calculator again, and I get the square root of 20. All right, so I'm going to go ahead and label that. All right, so now I know that perimeter is the sum of all my sides. So I have the square root of 20 plus 4 plus the square root of 20 plus 12. Okay, so I basically have 16 plus the square root of 20 plus the square root of 20. All right, so what I'm going to do is I'm going to add all of that in my calculator, okay, because it tells me to round. So because it's telling me to round, that means it wants a decimal approximation and not an exact answer. All right, and for my answer, I got 24.94427191. But when it tells me to round to the nearest hundredth, I know that it's wanting 2 decimal places. So my answer is going to be 24.94. It didn't give me any units, so I don't have to worry about giving them back any units. All right, almost done. It says name the quadrilateral with its most precise name. All right, so I'm looking at this thing, and I know that I have 2 parallel parts. I know that AB is parallel to DC, and I can tell that by visual inspection because the slope of AB is 0 and the slope of DC is 0 because there's no vertical change. So I know that those two are parallel. But I definitely know that AD and CB are not parallel because if I extend them out, I see that they're going to intersect. So I know that I'm dealing with one side of parallel lines, so I know that it's a trapezoid. Now, when I'm looking at a trapezoid, it does say its most precise name. So I have to ask myself, is this congruent to this? And I see that it is because I have the square root of 20 and the square root of 20. So not only is it a trapezoid, it's an isosceles. So I can't spell that word, so I have to think about it. It's an isosceles trapezoid.